All right, hope everybody's doing good. We are going to start talking about rational graphs. These are the most difficult graphs to kind of get a hold of. We're going to have two asymptotes, and then we're going to have four different areas that we actually are going to have to look at here. But really, what you really want to understand is that these two graphs are going to be very similar. We're going to do the basic graphs, and then we're going to have graphs later on that are not going to follow the actual rules that we have set forth, meaning that there's going to be holes in the graph. We're going to have jumpers, which means they are going to cross the actual asymptotes. So we're going to start out with the basic ones. Parameter changes are going to do exactly the same thing, only we're going to have to pay a little bit more attention to what's going on. But let's start out by looking at the parent functions. These are going to be the two parent functions for our graphs as we start out. This one is going to follow exactly what this one does. So we really don't have to worry too much about the squared. We're just going to square that at when the appropriate time comes. So let's talk a little bit about this graph. Well, the first thing is that everybody should realize that I cannot ever have a 0 in for x. That gives me an undefined term. Remember, when we have a graph and we have an undefined term, that means that it's going to be the location of the asymptote. So as x changes, if x is 0, y is going to be undefined. The other thing is that when we are talking about y, there is no value that I'm going to be able to place in for x that's going to ever make y equal to 0 as well. So now we have two different asymptotes. So we're going to have a horizontal asymptote, and then we're going to also have a vertical asymptote. So our horizontal asymptote is going to be y equals 0. So in this case, y equals 0, there's going to be our asymptote, and then x equals 0 is going to be our vertical asymptote. So x equals 0 and y equals 0. So those are the two asymptotic lines. Now, as we go, we're going to have this, and then we're going to be able to shift it. So if it shifts up, everything shifts up, left, right, down, up, or whatever. Okay, so rules don't change as far as shifting left, shifting right, shifting up, shifting down. But when the graph shifts, the asymptotes are going to shift as well. All right, so let's look at some particulars. We're going to stick with y equals x. 1 over x. All right, so again, if I put a 0 in there, we know it's going to be undefined. But what happens if I put a 1 in? Well, that's 1 over 1, which is going to give me 1, so 1, 1. What happens if I put a 2 in for x? Well, then that's going to give me 1/2. So it gets a little closer. And then the same thing's going to occur. We're going to get 1/3, gets a little closer, and then we're going to get a 4 in there, and that's going to be 1/4. So you can see as it approaches the asymptote, this yellow line being the asymptote, what's going to actually happen is that it's going to get closer and closer and closer, but never actually intercept that particular part. All right, so the interesting thing then is what happens between 0 and 1. So if you recall, back when we were dealing with some fractional things, if we have a fraction and then we have a fraction on the inside of a fraction, that means we are going to use the reciprocal and multiply. So this actually gives me a value of 2. So if I put 1/2 in, 1/2 is going to be a value of 2. So it's going to be up there. If I put a 1/3 in, it's going to be a 3. And I put a 1/4 in, that's going to give me 4. And this exactly is going to happen again. It's going to get closer and closer to the asymptote, but never actually intersect. So then what we actually have when you put the two together, for all the positive values, it's going to look like this. A little bit better picture. This is what the graph would look like. Now, that's the positive one. Now you can do the exact same thing on the other side of the graph. If I put a -1 in, that's going to give me -1, -1. If I put a -2 in there, that's going to give me a -1/2. If I put a -3 in, it's going to give me a -1/3. So you can see it's doing exactly the same thing. It's going to continue to get closer and closer and closer to the asymptote, but not intersecting it. So that would be our asymptote. Same thing is going to be true when we start talking about from 0 to -1. When I put in a negative fraction, reciprocal, that's going to give me a -2. So when x is -1/2, it's going to be -2. And then when I put a 1/3 in there, put a -1/3 in, that's going to give me a -3. So it's going to do the same thing. It's going to continually get closer and closer and closer, but never actually intersect. So together, they're going to look like that. So then the entire graph, once we look at it, you're going to have this part right here, and then you're also going to have this part right here. And remember, you're always going to have two asymptotes that are going to be inside there. So again, if you don't have a graphing calculator, you can go online. There's several different places. If you just search for a graphing calculator, there's many things that will come up. Make sure you put it in y is equal to 1 over x and y is equal to 1 over x squared. And then, of course, your h is going to shift it left or right. Your k is going to shift it down or up. Your a value, if it's negative, it's going to reflect it across the x-axis. So then we would take this figure, and it would be here and here if we reflect it across the x-axis. Then this point, which is our critical point, when you get to stretch and compress, they're going to get further or closer to the actual intersection of the two asymptotes. And you'll see that as you start graphing these things. So go ahead and put your values in there and try to figure out these rational graphs.